So it's a pleasure for me to or a privilege to have Maksim join here from Nebius AI. For those of you that don't know Nebius AI, I hope you'll get some sense by the end of the session to kind of what their cultural DNA is like, what they're working on. But in general, ever since we met them or I met them for the first time, I was really impressed. I think there's a lot of professionalism in the team aligned along with some really interesting things they're working on, including cost-effective compute and working on their own LLM, et cetera, et cetera. You'll kind of get a sense of today. And I think there's a lot to learn with them. Hopefully, at least some of you also will get a chance to work with them at some point, like I did. So just a bit about this session. This session, we're going to be talking about building the fine-tuning pipeline for alignment of LLMs. So I'm sure a lot of you have heard the word alignment, but never dealt with it. Some of you probably have like advanced understanding. From the prep sessions Maksim and I did, I think that you'll have, let's call it an intermediate understanding by the end of the session, and not a very, very beginner kind of one, which I think is nice. It doesn't mean that it won't be the same thing as if you've done it with your own hands, but I think it's a great place to start with. So again, please join the Discord if you're not there yet and introduce yourself, ask questions in the general chat and not here. I'll manage the questions kind of during the session. About the community, LLMOps.Space is a global community. We have events like this all the time, every couple of weeks, hopefully. Sometimes it ends up being once a month, but usually it's once every few weeks. And we already have a few thousand community members on the Discord asking questions, answering questions, and some other really interesting things coming up. Some interesting updates about the space. So Gemma 2 was released by Google in different parameter sizes. We'll see at least to some extent kind of the meanings of the different kind of trainings of the model in this session and other sessions. But I think both this one and the Phi 3 that we'll see, the bullet number 3, they were both benchmarks and both benchmark versus existing models, and at least in some ways are better. And that's it's always interesting to see, even though it is at least to some extent hard to keep track. And every time we have an LLM evaluation related session, then we talk about how the evaluation of the academic benchmarks is only partial, but it's always interesting enough per category to see what's the most interesting ones to work with. Kyodai, I hope I mentioned this correctly, is a startup that released a motion model that you can actually play with on their website. That's something that's kind of similar to OpenAI's GPT-4, the fact that it listens, speaks, and so forth, and it's a real-time native multimodal. And Meta announced something called the LLM compiler. The idea is it's foundation models in the field of compiler optimization. So definitely worth having a look at that. A bit about LLMOps.Space again. So recently we promised we would have a new website where everything kind of looked like a Notion. So this is the new design, more user-friendly and similar resources to what we had in the past. So this is what you'll see if you're kind of diving in today. And that's it about the general stuff. A bit about the agenda for today. So I'm not in charge of the agenda. I'm just going to be the kind of annoying narrator and host on the side and asking questions and so forth. But a bit about the stuff Maksim's going to talk about. So supervised fine-tuning and RLHF are two different areas. We've heard at least to some extent about them, but I think in a different and deeper angle. Some techniques for prompt tuning and LLM workflow management. So I think we'll get some sort of sense for what the alignment looks like, but just kind of separating the different topics here. So about Maksim, he's an ML engineer at Nebius, develops scalable pipelines for LLM fine-tuning and improving the chat capabilities of LLMs. I know it sounds kind of generic, like you might hear of other LLM engineers working on some sort of generic React chatbot. I promise you won't think that by the end of the session. Master's in computer science. And about me, in the day-to-day, I'm at DeepChecks doing continuous validation of LLMs and other AI models. And we're very deep in the LLM evaluation space. And specifically what I do kind of, let's call it the side job or in part-time, is the moderator of this space, of the LLMOps.Space, and have events like this all the time. if you or anyone else you know is interested plus relevant for speaking at an event like this, then it's pretty easy to find us. You can use this link or just reach out to myself or to Divi in the Discord. And yep, I think that's it. So Maxime, you're up.
Okay, Philip, thanks for this amazing intro. And I think I'll start my talk. Okay, hi everyone. I'm glad to be here. And today, hopefully, I'm going to tell you a lot about, well, some new facts about the LLM alignment and how to build a pipeline to align a model on your own. Let me start though by telling you a few words about Nebius AI, so the place where I work. Nebius AI is a AI-centric cloud that provides a full set of cloud resources like virtual machines, block storage, databases, and much more. So we basically cover all the steps of a typical LLM training pipeline, data acquisition to training to monitoring data, inference, all that. We're an NVIDIA preferred partner, so we actually have access to their latest and greatest and the most advanced GPUs, which are incidentally the most advanced GPUs in the world, thanks to NVIDIA being cool and all. We also have our own high-performance cluster and a platform designed by us that is tailor-made specifically for AI applications. And on top of that, we actually have a great team of highly experienced people that are managing all of this infrastructure. And I myself am part of this team. I actually work in our R&D division. So we have guys that use our infrastructure to develop LLM products. And I am responsible, as Philip told, for alignment in general. And more specifically, I design pipelines that train our model to continue long conversations. So this multi-role, multi-turn interactions, it's what's like part of my responsibility. And like in general, in our work, we face a lot of challenges when building LLM pipelines and tuning them. And we want to try to make them resilient, performant, and all of that. And so hopefully I'm gonna tell you about what we do and that you can use in your own experience. So, okay, let me start by telling you a few like obvious things. So an LLM pipeline training actually comes in two steps. Step one is what is called pre-training. Basically, you feed a lot of data to a model, a lot of tokens like Meta recently released their Llama 3, in which they used 15 trillion tokens to train a model and basically train it to predict the next token. It's a very expensive task in terms of compute performance. So they use like 16,000 GPUs running for an insane amount of time, and it was really expensive. But after that comes fine tuning. And actually, this is the step we're most interested in. And this is the part where an LLM actually becomes useful. Before that, LLM only learns to predict the next token, which is not really a useful thing. Here, we turn an LLM into a chatbot. Here is where the alignment actually happens, and we're going to focus more on that later in this talk. But so we are interested in this part. And coincidentally, it is much easier to perform. You only need a handful of GPUs. You only need a small, comparably to the pre-training amount of data. So like in the ballpark of several 100,000 to several million examples is enough. And it's not like really much when it comes to data sets of text. So now suppose yep.
Just 1 second, Maxime. So as you do this, as you do this next slide, I'm gonna release the first poll. So the first poll is so for participants here, the question is, what is the current development stage of your LLM application? So the options are conceptualization and design, development and testing, production and deployment, or optimization and scaling. So we'll let this run as you do this next slide, maybe one other slide, and I'll cut you off kind of to show the answers.
Sure. I want to vote myself, but Zoom forbid me from doing that. But well, I guess you know the answer, like my answer to this question. So yeah. Now imagine you have a problem, like a very particular task you want to solve with LLMs, be it making a chat assistant for your clients, or generating some code, some SQL queries, or like specialized language, or maybe you want to do LLM-based search with RAG, or I don't know, train your model to use some external APIs. There are like several steps to solving this problem. Like on the bottom, the first thing you can do is you can actually try to fiddle with prompt engineering. So basically design a prompt that accomplishes your goal, like I don't know, having several questions, several few short examples of it to your LLM. And it mostly works, and it works fine, but it works for limited cases. And another important part is it adds tokens to your context window, which is making all your requests, if you're, for example, using ChatGPT, more expensive. Now, what the next step to do is you might want to use some techniques that like efficient tuning, like LoRa or several other adapters, several variations of that. And these work like every step we go up, we get a bit more benefit, a bit more performance, a bit more efficiency from our design, but it is harder to do, and it requires more infrastructure or more skills to manage a bigger, like more dedicated experience. So the next step, and this is the step we're going to be talking about here, is where fine-tuning, like full fine-tuning, comes into play. And this is where we take a pre-trained model and we train it, fine-tune it for our specific set of tasks that we want to be able to solve. And well, at the top of this pyramid, there's always training a model from scratch, but like this is the territory only like a few other startups, Meta, Google, and all that. Like these guys venture into. They're like, I'm pretty sure that's not going to be for you, unfortunately, but this is how life goes. Okay, now let me return to alignment.
Yeah,
And
wait, one second. Actually,
yep.
Actually, I think now's a good time to show the poll results. So I'll end it.
Okay.
And share the results. So you can see here, there were 40% in conceptualization and design, 33% in development and testing, 21% in production and deployment, and only 5% in optimization and scaling. I don't know, Maxime, if you were the one that could vote for that,
yeah, I would have actually been a significant part of that, but okay. And
yeah,
it's interesting, interesting.
So let's see who can guess how many participants answered the poll just from those numbers. But yeah, 60% participated. So that uses the math riddle.
Okay. Yeah, so alignment is actually about teaching the model to answer how we would like it to be. So, and it boils down to two aspects. First is actually the structure of the answer. So for example, if we're having some sort of a structured output, like a SQL query, we would like it to follow the structure precisely. And the second part is about the values. This is more applicable to chat assistants, but like what the second part boils down into, it's actually the three principles. We want our answers to be helpful. So on the right, you can see an example of an unhelpful answer. This would be a much more helpful answer. We would like our model to be honest, so not to lie about having letters M in the word weather and be sure about that. And we would also like it to be harmless. And yes, this is the first most important part, but still, like asking it to build a bomb shouldn't give you an instructions on how to build one. It should give you a warning and a polite decline how to do it. Okay, and so now let's look at how we at Nebius do our alignment. We do it in two stages. So we start with pre-trained LLM, as always, and in phase one, we prepare the data set, which consists of the ideal answers, how we want our model to answer to specific user prompts. And we train it, and then comes the second phase. In this phase, we actually make a model output several answers to, again, our predefined prompts, and we score them. And then we use this scoring information to further train our model to improve its quality. As always, with ML, you don't forget to evaluate the quality of your model. And this gives us an aligned LLM. So now let me go through this pipeline in more detail, step by step. First stage. Yep.
Just 1 second as you're going to start. So the first question we got in the Discord by Diraj Sa is, what's the question? What's the difference between alignment and fine tuning? I mean, how is it different than one?
So. Okay. I think I can take this straight away. and actually point you towards this slide. So fine-tuning is actually a step in obtaining an LLM, and alignment is part of this step. And like, it's the problem with the word, it's too general. Alignment is actually one of the goals in this step. So we want our model to do what we want. So we want it to follow the structure, and we want it to be nice in these terms. And this like goal is achieved in the process of fine tuning. So hopefully that like addresses your question. It's kind of a mismatch, like a bit of the inner kitchen. We we ourselves had a discussion about like what's the difference between fine tuning and alignment, but this is the idea we've came up with to like relate those terms together. Okay, yeah, let me actually skip through this slide and move on to the supervised fine tuning. So this step, collecting data, we employed roughly 250 AI tutors. So basically dedicated qualified people to write us the answers for like as if it were the answer for our ideal LLM. And we collected roughly 10,000 completions of this form. And these completions are of different categories that you can see on the bottom. And on the right, here's a typical example of such a completion. So it consists of a user question and the model answer, and two important parts are the system prompt and the knowledge cutoff date. So a system prompt is just a general direction for the model, how this conversation, what role it should take. So your helpful AI assistant is quite a natural one. And the knowledge cutoff, it's more a technical thing. We basically do not want our model to lie about the future or the facts that it doesn't know yet. So we explicitly tell it that you know all the information, like all your information is up to this date. And we have collected this data set, but we quickly realized that some answers weren't that good. And what we did is we actually had to filter it additionally. And for that, what we did is we took a prompt and we made a model. So an aligned like open source model gave us the answers to this prompt. And then we compared them with the answers from the experts that we obtained. And so we removed if an answer of the expert was consistently worse than the answer of the LLM, we removed the answers of this expert, all the answers of this expert. And actually, it got rid of like 80% of our data, but it increased the quality of the final model. And so this might seem counterintuitive, like we've discarded a lot of examples, but still the quality was better. And now let me give you a couple, like a sort of an intuition why that is so. So consider a prompt and all the possible answers for such a prompt. And a pre-trained model has a distribution over these answers. So basically all of the possible jokes that you have are over there, and there's some probability that your model will output this joke. And what we want is steer this model, the distribution of probabilities towards the region that we want. And during training, model answers try to follow the training data set that we have. So if we approximate the region that we like with a narrow peak around this target region, so this is basically the data distribution. During training, the distribution of our model would get shifted towards this target region. And now compare this with lower quality data. This, for low quality data, this region is actually much wider, and the overall effect of training actually is diminished because there is like this wider, because of this wider region. So basically, if we have bad examples, our model would learn to sometimes output those bad examples, versus the case when we have higher quality data. So actually, but this phenomenon can actually also be useful to us, because its flip side is that we only need a few examples to kickstart a certain skill. And so here is a very concrete example of this. say we want our model to learn to output like structured text according to a given format. So here we have a JSON schema. We supply it to our model, and our model produces a valid JSON. We actually need only a handful of examples added to our training data set to make our model sometimes output those correct examples. And this effect would actually be picked up and amplified during the second phase of our pipeline. But first of all, a couple of quick words on how we actually train our model during this phase. Here we take all the conversations that were written by the experts. We take all the answers and we learn to predict the next token of an answer with our model. So this is like analogous to pre-training, but here we only look at like part of the data that is supposed to be generated by the model. This is pretty standard so far. So now comes phase 2. And this is reinforcement learning with human feedback, RLHF for short. And now let me get back to my intuition and give you some like further understanding of why this step is necessary. So remember, in supervised fine-tuning, we had our distribution, our final distribution shifted towards the target region. Here, we actually do the same thing, but we achieve it differently. Here, we actually look at the regions that are generated by the model, and we label the regions using humans. That's like where human labeling comes from, as either good or bad. So, and then our model learns from this information to output the good data from the good region more frequently, and the data from the bad region less frequently. Just a bit like further understanding of why this is needed, because one like very practical example argument is that this is actually cheaper because in this problem, the most expensive part is always generating data. And here we only need to generate the label. So we have actually to have a human look at the data and tell us which is good, which is bad. That's cheaper than versus like manually writing the prompts themselves and answers to those prompts themselves. And there is this added effect of training the model over its own data. So basically we can correct the mistakes on the fly. Okay, now let's go through how we do this step. We first sample the prompts, and we can use large data sets or small specialized batches. So if we want to train over certain specific tasks, we can do that. We then generate the completions for a model for this prompt. And here we actually use several strategies. We can use several models. We can use the previous iteration of the pipeline. We can use the output of the SFT model, or we can also employ several specialized strategies, one of which I'm going to tell you about later in this talk. Then we select the pairs. We need to get a pair of answers for our prompt. And here we actually use a thing called a reward model. So basically an LLM that scores answers and outputs a certain number for a pair of prompt and the answer. And we take the lowest, we take the lowest score from now it's kind of a misrepresentative from the slides, but we take a lowest answer of the previous iteration of our pipeline versus the highest reward answer from all of the other problem completions. And we form our pairs. And actually this step is also what allows us to filter the prompts themselves. So here's a quick question for the audience. Why do you think this might be a bad prompt to train on? I'm not actually I might wait for an answer, but yeah, let me give you straight away. This is a very simple prompt. All the models are quickly respond to it with an answer it's a circle. And so basically there's no information for the model to train on. We label the prompts, so we basically have a human tell us which one of them is better than the other, and we train on this data. A few words on how we train on the prompts. on the pairs of prompts, there are. This is a very vast topic, and unfortunately, I don't have time to even like touch it. I'm just gonna basically tell you like these two words. There are like two types of methods. One are the PPO-like, which distill the data about the scores into a reward model, and then they use an online reinforcement learning method, any generic reinforcement learning method, to train on this data with this reward model. And there are the second class of methods, which is the DPO-like. These are basically the DPO and its variants. These use the data directly, and we use the second class of methods because they're like more robust, and it's always better to have less intermediate steps. And
it's
these
more,
the DPO.
and it's
Yep.
the DPO, when you do it well, is a bit more expensive, right? Because then you have to like somehow get more high quality and so forth, right?
Yeah. Therefore, our pipeline needs to be scalable and provide us with more quality data. Yes, this is kind of like trade-off that we've like how we resolve this trade-off.
Right. Just 1 second before you move. We have a couple of questions. I was waiting for a good time, but now you got a few of them in a row. So
Yep.
So the first one, another question from Diraj. The question is, are we aligning model while fine-tuning or after? So there's a diagram, I think, at the end that'll make everything pretty clear, but maybe you could already answer that now.
Yeah, I would say that we're aligning it while fine-tuning, because during fine-tuning, we pursue several goals. We, for example, want to train it new skills. We want to make it less harmful. We want to make it use some, I don't know, different languages, like generate code, or maybe improve its like generation skills in general. And this are all the different goals that we can achieve using the same technique that I'm like explaining you right now. So like fine tuning is a process. Alignment is, I would still say, it's a goal, and we achieve it while doing it. Yep. So
all right. So maybe I'll say one question that wasn't exactly asked, but was asked. A few people asked me in other contexts on the same topic. So the difference between alignment and then like evaluation and corrective action. So I would say alignment it's exactly related to this question. Alignment is happening like during the training, but then you could also do after the training. You could do the same type of process where you're correcting like it with prompt engineering and limits and stuff, but not going back into the training part. And that's like evaluation and corrective action. So it's kind of related. You might have some things that might feel a little similar, but I think it's a bit different.
Yeah, actually, I'm moving to this part that's going to be very illustrative for this very particular question. So
all right, but just not to break you up too many times, I will ask the other couple of questions here. So Lagamerson, not sure how to pronounce that, but that's in the Discord. Said, host, please correct me if I'm misleading, but alignment is an objective or goal of fine-tuning. Fine-tuning is the mechanism to align a model, among other things. You validate this alignment after, but align during. So I think that has to do with what we just talked about now.
Yep. I agree with this statement. It's true.
Right. And there are another couple of questions within the Zoom chat. Please move everything to Discord. It's a bit hard for me to manage both of them. So I put the link in, and feel free to answer over there. I think there was a question a while back over there about if you could show an example, whatever. I think you did start to show examples, so I think that's closer. They want to see code, but I think it's all a question of how you present it. You can ask for more things offline in the Discord, and I'm sure Maksim will be happy to share later on.
Yep, Philip, thanks for this. Like, good job. I wouldn't have said it better myself. So, okay, let me like give out this last part, and then we can maybe have a discussion on all this. I understand that like it's spurred a lot of questions. So, okay, one thing that I promised you earlier about specialized strategies of how to generate prompts, and here is going to be there's going to be a very concrete example of what we can do. So here we actually are going to solve a very specific problem. So say we have a model that outputs really long and rigorous answers. And we wouldn't really want to have those, I don't know, as a quick chat assistant. We would like to have something shorter and more concise. So how we can do this? Well, we can actually alter some inner parts of this message being the system prompt. And we can actually use this to change the behavioral model and then distill this knowledge into the general system prompt. So we can ask a model with a shorter system or with another system prompt to, well, in this case, to give shorter answers, and it would do so some of the times, but we would still want to use it with an original system prompt. So what we can do then is we can swap the system prompt and use this completion as a completion with an original system prompt, and basically move it through our pipeline of labeling pairs and generating and RLHF step of the pipeline. We hope that we think that our labelers would count this prompt as positive one because, well, we told them so. We would like shorter answers rather than longer ones. And then we use this information to have our model generate answers with a default system prompt, but the ones that we need. So this is kind of a very interesting trick. It combines the effects of post-training alignment, but it bakes them into the fine-tuning step because, well, to make it more long-lasting and less dependent on the specifics of the system prompt that you have. Okay, wrapping up here, evaluation. Never forget that, but still, the bad news here is that we don't really have a single metric that tells us how good our LLM is. We at Nebius look at 3 classes of metrics. First, we have the general score, which is the side-by-side comparisons with other LLMs. We can do that, basically have a wide variety of prompts and make our models ours and other models answer to those and basically compare the answers. We can look at the average reward. This is a good first guess and a proxy metric. We can use it in the intermediate steps to measure the quality. You've seen it used in the pair selection process. And we can also measure several benchmarks for scores like MMOU or MT-bench for multi-turn interactions. We can use needle in a haystack for long context and all that. And these give us a very discrete standardized number for a specific performance in a specific task. Okay, wrapping it all up. Remember this slide, this pipeline. Well, we can actually fill in the missing parts here and outline everything. And here is how it looks. So we have
this, by the way, is the slide I was referring to when I said it, where there was a question at the beginning about what happens when. So this is the slide that, for me at least, was a big deal. It really helped me kind of structure in my mind the different processes.
Yeah, so it basically boils down all of what I was talking about into this one chart of what's going on where, but hopefully you've grasped what each block of this diagram means. Okay, and now here comes the I have -7 minutes. Wow. Okay, here's gonna be a very bad part for you because all of this up to this point there was it was mostly theory. It was a world of block schemes and all that, but in practice it's a bit uglier. So real quick, in practice, what we do, we have data collection. For data collection, we partnered up with Toloka AI. They have
just 1 second, Maxime. As you're talking, I'm going to do poll number 2. So poll number 2, we're asking, what is the parameter count of the LLM that you're using currently? I know this is an ambiguous question. Maxime and I talked about it, but we said we'll have a good enough one. So of course, if you're using OpenAI, whatever, then you don't know, right? But let's just call that over 7 dB. Everything else is the answers are less than 7 billion parameters, which, by the way, we in deep checks don't call that an LLM. I know there are different ways to define it. 7 to 13B, then there's 13 to 33, which I think one of the ones I just shared of Gemma was 27, but I think it's less common. 33 to 70B, and then over 70B. I think, Maxime, your thought about this was, what do you do, in cases where there's a combination of a few and so forth, right?
Yeah.
So, just choose whatever
Give us
you
the
want.
total parameter. Yeah.
Yeah, either just sum them up or anyway, I think that's a good way to look at it. So continue with the slide and I'll show it at the end.
Yeah, sure. So, okay, stick with me for a second. For data collection, we use Toloka. They're actually really great at designing those crowdsourcing pipelines. They hired the AI tutors for us. So basically, it was them who provided us with all the data that we requested. For orchestration, and it is like important part here because we won't, or we don't want to don't want to miss any data. We want to monitor all failures and all that. We use Airflow, and this is a good enough solution for us. It's really robust. It has a good support and community around it. For dataset storage, we use Tracto AI, and it is what allows us to basically save the checkpoints of our models and have the data sets, do all the data transforms with them. And this is part of the Nebius, one of the solutions provided by Nebius. For monitoring, we use the data lens as part of this Tracto AI package. It's good for tracking the state, the metrics, and all that. We have various alerts and notifications and basically fail-safes to, first of all, notify us if anything goes wrong. We would always want to know if something goes wrong in your pipelines. And the important part in this is that this pipeline that was explained to you actually runs daily and accumulates data over time. So basically, we have the data, the RLHF part is about using the most recent model and adding data to it, which are the generations of the latest model. Okay. I hope this slide will start a discussion, maybe here and in the Discord chat. Feel free to ask all the questions about this particular slide or all of the previous presentation. And I guess with that, I'll wrap up my talk. And again, thank you guys, to all of you for listening. Thanks, Philip, for having me today. And I'll be happy to answer all your questions now that it's done.
Amazing.
Okay.
So just a few questions you got kind of as we were talking. So one of them from Marcus Rodrigo in Discord is, what would be an estimate on the resources needed for fine-tuning an LLM? Let's say Llama 3 to 8 billion, number of GPUs, number of training examples, or their size in gigabytes, training time, and so forth. So
Okay.
that first of all, Maxim, I think after the event, maybe you can share some more resources there or just answer the question in more detail there live, but let's try to already do something kind of live.
Okay. Yeah, sure. So when I was talking that alignment is much less resource intensive. So like a single host of 8 GPUs is enough to train Llama 3 8B on, like, fully train it, fully fine tune it. Sorry, training, like in this context, is always like fine tuning part of training. The training time itself really depends on the data set and the hyperparameters. Usually, okay, I'm gonna go much into detail here, but like a couple of epochs is usually enough. So like 5, even like lower than this. And when you have a data set of several thousand examples, in our case, we had 2,000 plus whatever we added in the manual part, we had training times in the ballpark of like half an hour at most on the 8 GPUs with the hyperparameters that we're using. So like always, these are the estimates. It may depend on your specific hardware, on your data set, on the like tools that you use, but these are like my numbers and they're pretty consistent with the rest of the team.
All right, amazing. I think another question that we have is if you can use LLMs to label instead of human labeling in the phase that you had human labeling.
Yeah. Okay, so basically there's this open problem of developing an like perfect, good enough labeling system And this is where the PPO methods really, like, this is connected with PPO methods because they want to train a reward model. It is possible. I think it might be possible to do so, but it's kind of a chicken and an egg problem because we would imagine to have a good labeler also needing a lot of data and having a lot of like manual data, collecting that would need humans. And for us, it's actually, as I see it, at this point, LLM labeling is a way to cut costs because, well, you have one thing you have to evaluate. You only use the electricity versus paying real humans to do that, but their quality hasn't actually really like reached the level that we will be comfortable with replacing humans. So, like, if the question is if the question is it possible, my answer is yes, because I strongly believe in AI. But so far, with the resources that we have and with the kind of the goals we have set in mind, it's better for us to use human labelers still. So yeah.
All right, amazing. So I think one last question I'll kind of answer partially, maybe add something, and then I'll share the polls, and then we'll finish. So Srinivas asked us on the Discord, those tools in the pipeline that were mentioned for data collection, orchestration, storage, and so forth, are they used in Nebius, or are they the recommended stuff? What are the options? How does one go about selecting them? So I'll say on my end, first of all, I think Maksim is being a little modest here. I think the Nebius team is an amazing place to start when you're doing fine tuning. So I would definitely talk to them. I think maybe he wouldn't want to kind of market themselves or whatever, and it's good, but I could say that. I think that there are a lot of resources in one place, and also the team has been doing this in different variations for a while. So I think you'll get guidance on top of the hardware. So I would definitely try with them. And then for the other tools that I mentioned, I know some of them, at least Maxime was just saying, I think what he and the team were using, but yeah, but feel free to expand on that.
Yeah, Philip, that's actually like it's correct. That's what we use in our team, and that's what we have built. All of this I was talking to you, like, presenting to you on this stack. As far as like each particular choice goes, it's like a huge topic up for debate in a Reddit thread or like in a team, a lot of syncs and Zoom calls. For us, it was like in each step, it was like a decision based on the like all the our goals and compromises we had to make. None of them is perfect, as nothing in this world is, but like this is what we settled on as far as the tools go. So I wouldn't like go as far as to say that this you should be using for all and every application you want to design. You might have your own situation. You might have an easy access to some other tools, for example, think for yourself. But these are workable, and you can build something cool using this stack. And well, that's really what a stack is for. It's not for being perfect, it's for being useful.
Amazing. So last thing we'll do, I'll end the poll and share it here for a second. So for me, it wasn't surprising. I'd wonder about you, but what is the parameter count of the LLMs that you're currently using? So the 70% was less than 7 billion parameters, where again, I say I don't even count it as an LLM, but there are different methods for this. And there's 7 to 13, which is 37%, which is not surprising. I know, Maxime, in our prep call, you said you think Llama is very common. So I think I see Mistral as a special 7B model. I think that's optimized for fine tuning that that I think is really interesting to kind of have a look at. And I think probably Mistral is also one of the common ones. 7%
Yeah.
for 13 to 33 billion, 33 billion to 70B is 17%, and then over 70 billion parameters is 22%. So I'll stop sharing now. Anyway, I'm sure you have a million other questions, and that's a perfect time to tell you the discussion does not stop here. It continues on Discord. I sent throughout the event, you see Maxim's email over here feel free to reach out to Maksim, to other folks. I sent a link to the Nebius AI website. It's also not hard to find. And LinkedIn, Discord, there are different ways to get in touch with Maksim. And he was definitely the more interesting one in this call, but you also know how to reach me pretty easily, LinkedIn or Discord. So thank you so much for coming. See you at the next event. And Maksim, keep up the great work.
Okay, again, Philip, thanks for having me, guys. It was a great pleasure to be here, and thank you. And I guess it's goodbye. Well, it's bye-bye.